on the insects of southern Africa, but it's quite wide in its application. So the first one there is the pupa exorata, then pupa obtecta, and pupa cartata. Now we'll be dealing with the middle one there, which is pupa obtecta, and in this type the appendages are pressed against the body, as you can see, and cemented to it by a secretion produced during the last larval molt. It is common in all higher Lepidoptera. So back to our life slides, and we can see there the chrysalis splits open ventrally along a seam just behind the butterfly's head, and it's also clear how translucent that chrysalis has become. Hemolymph or insect blood gets pumped into the wings. You can see the abdomen is still full of hemolymph, actually overfull. And in this slide, hemolymph is still pumped into the wings, but what's clear here is the coiled tongue or proboscis, the siphoning tube, and you can also note the split at the tip of the tongue, like two straws fused together, and that's to enable it to feed on nectar effectively, especially nectar of particular flowers. Now there the wings are still shrivelly as hemolymph is continually pumped into the wings, and the wings eventually straighten out under tension, as in that slide, and then it's readying itself for first flight. There it is in all its splendor, a beautiful monarch butterfly. This is a male. You can see the scent glands or pouches there, which sets it apart, and the adult stage is about 2 to 6 weeks or 6 to 8 months for the fourth generation in order to migrate, although the migration does not occur in New Zealand, only in North America. And I'll read from this book, Which New Zealand Insect, of Andrew Crow, on page 11, I believe. It says the following: the monarch is the only butterfly in the world known to regularly undertake a two-way migration. Indeed, one female holds the record for the longest known insect migration, having flown 3,432 kilometers from Canada to Mexico. At average speeds of up to 130 kilometers per day, this journey would have taken almost 1 month, flying at altitudes of up to 1,000 meters. Each year, at the end of summer, at least 100 million monarch butterflies make a similar southward journey to the mountain ranges of Mexico, where they hibernate in the pine forests. At the end of winter, they mate and start on their long journey back north. The most incredible thing about this northward journey is that it takes up to 5 generations of butterflies, leapfrogging each other until the great-great-grandchildren find their Canadian summer home again. How do they know where to go? No one knows. I'm sure God knows, because He designed that. However, this rapid transformation of a monarch's metamorphosis speaks of instantaneous creation as opposed to tardy evolution. And there's that slide of speciation, as we'll revisit that quickly. Thinking back of part A that we did last week. The top there is an example of allopatric speciation or allopatric, where there is separation, geographical separation between species 1 and species 2. However, sympatry or sympatric species occur in the same geographical area. There's no separation of those populations as they occur together. And that's according, or actually modified after Odom, published in 71. That's actually microevolution or low-level variation. And suffice to say that a species is a group or taxon of organisms capable of interbreeding. Now this is the Californian salamanders example that I wanted to show by means of a short video clip. There you can see in the picture there is David Wake of Berkeley University, and he explained divergent evolution in that clip with salamanders, the ones on the left there being the ones on the one side of California, the one side being coastal, the other side being inland and foresty, or forest biome if you will, and the ones that are mottled like that, that might be a hybrid, but suffice to say that the colourful ones were the ones on the coast, and they were also the very poisonous ones, whereas the ones that were inland, as they migrated down over about 200 years, they have reverted to become more cryptic or camouflaged, but they weren't poisonous, so they did not advertise that they were not, obviously, for the sake of minimizing any predatory pressure. So what David Wake then concluded was that this was an example of variation, and in fact proof of Darwinian evolution over millions of years, although this is an example of only a few hundred years, whereas salamanders still ended up as salamanders over the divergence that occurred between the population on the coast and the population in the forest. So basically, after all that hoo-ha, we still have salamanders, and that's my point. That even given millions of years, had there been millions of years, salamanders would not have turned into something else except a salamander-like animal. For instance, lizards could become legless, and you get legless skinks due to a loss of genetic information, but it's not possible for that kind of animal to change into another kind of animal according to evolutionary theory. So we oppose that on that basis. We can also look at the diversity in dogs. And realize that this is artificial evolution or selective breeding as opposed to natural selection, and you can see the vast differences of the different dogs in terms of size and all sorts of other features as well, yet they are all one species. They all come from that ancestor, Canis or Canis lupus, the grey wolf. So all domestic dogs are known to have come from that animal. So even with evolution sped up by humans in the breeding of domestic dogs, or the domestication of that animal there, the wolf, we still have dogs only. It's not possible to use that genetic information and reshuffle it or allowed to get lost and get another kind of animal from the wolf except the domestic dog. It's not possible, for instance, to get a cat or any other kind of animal, even over millions of years. That is simply impossible. Canis lupus familiaris, which is the subspecies of the wolf, the domestic dog. So for those of you who don't know, that's the genus, the species, and familiaris, the subspecies. So they all belong to the one subspecies. And consider, for instance, now the ratites or the moa that have gone extinct in New Zealand. You can see that they're all pretty much the same kind, as the Bible refers to, of different kinds of animals, giving rise to their own kind, not to different kinds. And it's there that we should focus our research efforts using a biblical worldview, I believe, to determine where those barriers and limitations are in terms of the systematics. But they're not continuous, like evolutionists would like us to believe. There is Dicornis giganteus, and this is, for instance, this black one is Emus crassus, vastly different in size and classified into different genera, let alone different species. However, if we look back at the domestic dog, we not only have them in the same species, but in the same subspecies, and at the higher level in the same genus. However, there we have a different genus of Dicornis giganteus than Emus crassus, for instance, and the rest, they are all, or most of them, belong to different genera as well.
Can I just clarify? So what you're saying, Victor, is that on the one hand, a whole lot of animals that are vastly different from each other are classified very tightly together. On the other hand, these animals that possibly don't even show quite as much divergence are considered to be a whole range of completely different species and genre.
Yeah, I believe...
So it's not at all consistent in how it applies the concept.
That's my view, because here we have a known history, because of human documentation and so on, of these changes, or microevolution, if you will. It's not even speciation, because it's still at subspecies level. And for the moa, we don't have them with us. They've died out 500 years ago approximately. We have no records of them other than their bones.
But it could have just been like large and small dogs and different coloured dogs.
Exactly, so it's just a taxonomist decision to have put them into different genera. Exactly. Right. Whereas if we had them alive today, we might have considered them differently and even closer related.
Based on whether they interbred or not? Or
yeah, on various factors that we cannot test for just looking at the bones or fossils. So basically the Bible would consider this one kind. So maybe at family level, that's how taxonomists consider them, although that's already considered macroevolution. But actually I might still consider this a low level evolution, which is allowed in terms of species adapting to their local environment or kinds, which is a God-given trait or feature in the genome of the different kinds of animals.
So but that's the dog that may also all descended from one animal.
Yeah, so exactly. So the wolf we know must have gone into the ark with Noah.
Yeah.